At all one, there's a all. So there's also all. The liquid should not spill out. What should be the acceleration? Objective question definitely means they want to, instead of lengthy calculations, no, they just want to test students. Okay, there's a point one. So we'll begin. There's a point one. There's a point two. Writing manometric equation. So pressure at 1, P1 plus rho LA. If you move against the container, rho LA minus rho GH minus P2 equals 0. Look at both the holes exposed to air. So what should be the pressure? P1, P2 equal to P0. So what is A equal to? A should be equal to GH by L. If the acceleration is equal to this much, the liquid will not spill out at either of the hole. So what do we think? Sir, here, okay, liquid will not flow out. Okay, fine. But here liquid must flow. If it is at rest, the liquid will flow out. They will come out like this. If I accelerate it, the liquid will not flow out. So now it is possible. The mathematics is saying, no, the concept is saying. It's not like something sealed. Both ends, it's open here. All or some all means again small thing, so open end I'll write it. I think this will reflect. So now you can expect really some good set of questions. Till now what all we discussed is all about only the liquid filled up in a tube or tank or thing. So you can go for any RBT shape. So any RBT shape means if there's a liquid is there. I'm trying to generalize it. I'll partially fill up. There's a spherical shell. So I'll partially fill up. So this is the vacuum. And this is a liquid. Initially, for the test, this would be the situation. So if it accelerates, what conditions will arise? So you now what happens? Slowly migrate to the different ideas. Slowly you have to migrate to different ideas. Different ideas means liquid filled up in a different shaped containers, partially, fully. What conditions can arise? So I think now shall we make it? Something it can happen. It can happen like this. It's a half fill, no? So this can be one position. I think through diagram only it will be on safer side. Where pressure, okay, let me go for pressure at what do you expect pressure? Where it will be more, at 1 or 2? So let it have acceleration A0. What about pressure at on the free surface? Pressure of free surface here if I say air, then you can go for P0. Air, the pressure will be P0, you can assume. So here you can bring atmospheric pressure. Since if I say vacuum, so no question of any atmospheric pressure inside that. So what is the pressure on the free surface? Will be 0. Because if air is there, then only the P0 will come into picture. I think, see, shape of container doesn't matter, sir. So here pressure at 2. So what is this length? This is a radius R, no? The pressure at 2 is what? The radius R. So pressure at 1 and 2, shall I say equal? Yes, it should be. Provided if A0 equal to G. Pressure at 2, I'll write equation. Pressure at 2 will be rho A0 R. Manometric equation, P0. Okay, sir, how you are writing, why you are making guess? Okay, no, let it be like this. P0 minus P0 plus rho, I think I'll write C. So O, some of you are getting confusion. Let me make C. PC plus rho A naught R minus P2 equals 0. PC is equal to 0 because the vacuum. So therefore, P2 equal to rho R A naught. PC plus rho GR minus P1 equals 0. So when pressure at 1 and 2 will be equal, when A naught equal to G, it will come. Okay, sir, what about here, sir? I'm interested in this particular point. Okay, no, see, just getting to the manometric equation. I think I'm making things very clear for you. No. So what about pressure at 3? So you write in terms of 4. So PC plus, I'll get into the PC plus rho G R cos theta minus P4, the PC is 0. Then if you know P4 plus rho A naught R sin theta minus P3 equal to 0. I think a student has to learn writing manometric equation. Nothing to do with container. So what is the problem with the container? Nothing to do with container. No? So students, I don't know. So you start thinking different way, innovatively, creatively. Nothing, just manometric equation. So today, what happened? Your entire the week syllabus you can split up only into 2 parts. What is that? Manometric equation. The liquid will exert force normally on all surfaces. It comes in contact. I think any student just gets an idea. These 2 is enough. No need to sit from Monday to Saturday. Because you take any problem today, this week, you pick up any problem. This is the thing what is involved, no? Generalization, simplified way of thinking. We are just doing different problems so that we are learning how to use that idea in different cases, that's all. But what your physics sir has taught you in this week, all 1 week, what he has taught only these 2. How to write manometric equation, then like a calculation of force acting on surfaces on which liquid comes in contact, and that force will be normal, that we call like a thrust force. See, like this generalization, when do you get it? When you solve different problems. And again, what happened on Friday evening, what you should do, you should compare the numericals. Oh, I learned this problem like this, I learned this problem like this. Then okay, how they are related. A student can generalize like this, then he is in a better position. Please do, because in physics, this is what needed. If you look at one side physics, you feel you are learning many things. But if you look at from other side of coin, you are learning very less. Let's go for pressure in rotating fluid